Some more to join?
Yes, sir. Yes, only 12 joined.
Okay, shall we resume?
Yes, sir.
Okay, okay. I think I may not be able to write. Okay. Otherwise, I have to share one more. Okay, so our goal is to see whether the difference between these two vectors, right? So xb represents the word vector representation of the word B. So for example, women, and this XA represents this, so man. So the difference between these two, right? So difference between these two must be equal to a word that is being offered by the system with respect to king, right? So we expect the difference between the vector man and women must be something similar to the difference between the word vector king and the vector that is being offered by the system, right? So if we are getting a word which is closer to, right, as a word similar to women with respect to king, maybe we can say that our word vector representation is somewhat good, right? So the only assumption is assumption with respect to distance between vectors in the vector space. Assumption is we actually wanted to see similar words will be placed very close to each other in the vector space. So that is our assumption, right? Or maybe we can bravely assume that. Just give me 1 second. Okay. Okay. So, what is this? This is basically the dot product, right? Dot product between the difference between this plus xc transpose and the word that has been picked by the system divided by the L2 norm of the thing. So this is nothing but A dot B divided by L2 norm of A and L2 norm of B, right? So that should give the vector D. Right? Very, very simple argument, and you take the maximum out of that. So argmax represents which will give you the maximum value for this with respect to all the vectors that is there in the system. You test it and you take the maximum argument from that. So that will be replacement for this D, and so you are expecting something here. So if you are expecting queen will be the maximum vector that is been given by this equation, right? So any questions?
So this is actually a one-hot vector. We are using the one-hot vector, right, for this?
Yes. Yeah. So basically, not the one. Basically, we have constructed word-to-vec representations, right? Or we have created glow vector representations, right? So we wanted to take two vectors from that, right? And another, we are expecting they are very similar to other two vectors. So we took man and women, right, two vectors, and we took a king vector, right? And we are trying to find out all the possible representations of all the representations in the vector space, so that we will be getting a vector similar to maybe to replace here the question mark.
Okay.
Right? For that, what we have to do, we have to take all the i's, all the xi's. Xi's represents all the vectors that is there in the vector space except these three, right? And we take this and we calculate, and we calculate the maximum value out of that, and we represent that this is D, right? So what could be the difficulty or a problem with this kind of an evaluation scheme? What do you expect? Whether it is a good method or a bad method, depending on what?
Hello?
Yeah.
Sir, here we are identifying with argmax of I, sir. We are calculating with all the words in the corpus.
Yes.
So that is a high computation procedure, I think.
Okay. Computationally, it will be. It may not be that much difficult, but as the space is large, maybe you may have to spend some time. But the calculations are very simple, right?
Okay.
It's very simple. So I don't think it will take much time. No, I'm just asking about maybe we have made a very simple assumption. We have a bunch of word vectors which is computed by some method, and then we wanted to compare this, right? So what could be a difficulty or what could be a problem with this type of a method in analogy kind of a task? So one difficulty could be it depends on the domain you are working, right? If it is a very generic kind of a domain, maybe this point we have discussed in the previous discussion as well. If it is a very generic domain, then the vectors that this will throw out will be a lot of vectors you can expect, right? So that will be a difficulty. So if it is a very domain specific kind of a thing, maybe you can expect a good result. Otherwise, it will be a difficult task, right?
Okay. It
So-
will provide the same result at every time. Is it, sir?
Yes, yeah. It will give same kind of result. Yes.
Okay.
So, can you tell me in the vector space, when we seek for cosine similarity, what is actually been searched in the vector space? When we say two vectors are maybe close to each other, what we are actually trying to measure?
Those two words are almost similar, sir.
Yeah. In the vector space, what does it imply? The two vectors are close to each other means what?
Angle will be very less.
Yeah. Basically, those two vectors will be pointing towards the same direction. That's the meaning,
Okay, sir.
right? If they are pointing to the same direction, they are same, right? If they are mutually perpendicular, then they are not same, right? So that's the meaning. Maybe you take the cos 0 and c, and cos 1. So you are trying a maximum value here. That's why arc max of D, right? And please remember, we are actually trying to see whether semantically they are semantically similar or syntactically similar, right? So we are expecting semantic similarity is being captured by the word vector representations, right? So let us see some visualizations which is taken from some papers. You can see here, yeah.
Sir, one doubt, sir. Sir, actually, that dot product you said, whether we use the concept of dot product only, or we are computing the dot product for these two terms. Because usually while computing the dot products, we multiply the corresponding terms and add.
Yeah, that's what in the formula we are doing a multiplication.
But in formula we have only single term inside the bracket, sir.
Yeah, these are single. See, basically what we do is b minus xa. So these all are vectors, right?
Okay.
We take the difference between these two, right? And take this word here, so add it, right?
Okay, but my doubt is actually, suppose we have two vectors, say a1 plus a1i plus a2 plus a3j and b1i. So in that case, the dot product will come as a1 b1 plus a2 b2 like that, sir. But this term is not in that form. That is my doubt.
Yeah. We are actually concentrating on the analogy kind of a thing, right? We have our problem is whether analogies are there, right? Man to woman is whether it is equal to king to queen, right?
Okay.
So we have recasted the problem as difference between these two vectors plus this
King. Oh, okay. So we take the product like that. Okay.
Yeah.
So we treat this as a single term. Okay.
No. This transpose is basically to represent the vector in the maybe column format or row format, and this is column format basically. So basically you are multiplying it, right? And divide by square root of maybe the squares of this, right?
That's also my next doubt, because while computing that unit vector, then only we take that denominator, right, sir? Simply taking dot product, actually it's
protractor. It is used to find the angle.
This is angle basically. This is angle, right?
Okay.
Cos theta.
So that cos. That angle itself. Okay. Yeah.
So whether it is 0 or 1, so E actually falls between 0 and 1.
Then return it. It's not good to steal.
Okay. So A dot B by that modulus A into modulus B, that form, right, sir? Okay, sir. Okay, sir. Thank you, sir. Thanks.
Okay. And you can see somebody has to mute.
Protractor.
I think Anagan.
I think I have to.
Yeah, sir can mute. Sir.
Okay. So this is just a visualization of the concept. You can see niece, aunt, sister are coming closer, right? So you see this cluster, right? And man, women is very far, right? So semantically they are far, right? But these concepts are somewhat similar. That's why they are clustering each other. So similarly here, right? Right. So this is one visualization, and this is, I think, some company and CEO kind of a relationship, right? So I think similar kind of a companies maybe should cluster to each other, something like that might be. Right? Verizon and Vodafone are maybe telecom related companies, right? So these two CEOs should come closer because they are working in the same domain, something like that. Yeah. And here you can see comparatives and superlatives. So slow, slower, slowest, short, shorter, shortest, kind of a thing. So you can see almost they are spaced equally spaced. So these three concepts basically, the slowest comes here, right? Shortest comes here. Similarly, you can see here, loudest, clearest, softest, darkest, all are coming this side. And this louder, clearer, softer are coming somewhere here, right? Then clear, soft, dark, those things are coming here. Yes? Yeah. So these are some experiments they have done with different models, SVD and continuous bag of words, globe, etc. So you can see their results, semantic and the syntactic similarity and the total similarity. So globe vectors gives better results. Right? And these are the hyperparameters that we have to fine tune. Maybe the dimensions. If dimensions are kept same, but to improve the things, maybe you may have to work with the hyperparameters and do the experiment again and see the results. So yeah, this is analogy evaluation and hyperparameters. So these are the different data sets that is being used. So green represents the syntactic and this violet represents the syntactic and green represents semantics. And this is overall. So you can see the accuracy plot with respect to the vector dimension. So you can see when dimension increases, I think accuracy also goes high. So somewhere around if it is more than 300, some kind of accuracy above some 70 you can achieve. So that's what this diagram shows, right? And Wikipedia is better than news text. So this is the thing I was just mentioning. So so why this statement? Wikipedia is better than news text when you construct word vectors. So Wikipedia will have maybe related words. Wikipedia basically you have an article, right, and you keep on writing a similar story in the Wikipedia document, right? But in news text, news differently maybe you have very different kind of news that is coming up, right? So if Wikipedia is let's say science related pages, if you take, right? So there is a chance that you will get more and more vectors which are maybe closely related. But in news text, there is a chance that unrelated words might be appearing, right? So that's why this statement is made. Wikipedia is better than the news text. So there are other works. So with human judgments also, it has been done. So you can see word 1 and word 2, tiger and cat, and human being. They actually ask to give a score. So higher score means they are similar to each other. So book and paper, semantically, right? Semantically, they might be closer, right? So that's why there is a high score. Computer and internet, maybe computer science people will not agree with this, but for layman, computer and internet are somewhat closer, right? A plane and car, not that much closer, but there is a value given, but both are used for maybe traveling from one space to another space, right? One place to another place. Professor and doctor, maybe. Yeah. So Stoke and Jagger, right? So this is a work that has been done with WordSim 353 dataset. Then correlation evaluation is also been done. So, in globe paper they have maybe skipgram model as well as maybe continuous bag of words model also you can use to construct that. So this is word vector distances and the correlation with the human judgments. So here also you can see there are different models used, right? And the size of the data set. So as data set increases, you can see the globe method shows more correlation, more value, right? So more correlation with many data sets, right? And this one is basically extrinsic word vector evaluation. So in the intrinsic word vector evaluation, what we have done is we have taken the words and we have taken the vector format and we have taken one task, which is analogy task, and we have compared how far the method is giving closer vectors, and we say that the globe method performs better than the other methods, right? So similarly, in the case of extrinsic word vector evaluation, we have to do a complete a real world problem. We have to attack that, and the problem taken was named entity recognition. So basically, you have to identify references to a person, organization, or location, right? So Santosh works with QSAT, right? So and QSAT is located, or QSAT is at Kalmashiri, right? So Santosh is a person, QSAT is an organization, Kalmashiri is a location, right? So that is basically NER, named entity recognition. The entire task is being evaluated. So these are the some of the results. You can see most of the data sets, globe works better. So another classic problem in NLP, maybe we will attack this problem later, but I just wanted to mention it here. Basically, most of the words will have a lot of meanings, right? So especially common words will have a lot of meanings, right? Or words that have existed for a long time will have similar, maybe there are other meanings associated with those words, right? So for example, a word pike will have a lot of meanings. So the natural question could be, does one vector capture all these meanings, or do we have a kind of a mess? Okay. So pike, if we convert this as a word vector, maybe we can expect only one vector, right? One word, one vector. So whether this pike will represent all the meanings. So for example, pike has meanings like it's a sharp point or a staff, a type of an elongated fish, or railroad line or system, a type of a road, maybe the future, right? So lot of such words you can identify, right? So NLP, how NLP is going to deal with this, right? So usually, if such words are coming, we have seen that it depends on the context, right? So remember our first class itself, where I have mentioned the word bank, right? So if context is something similar to corruption or maybe some stock market, something like that, the bank should be related to the commercial kind of a bank. Or if maybe the seashore or something like that, it should be a bank which a river bank, right? So depending on the context only, glow vector and word to vector kind of representations take the meaning to the vector, right? So maybe that is already been taken care, but even in a text there might be such common words coming with different meanings, right? So there are a lot of ambiguities, right? So how we are going to deal with these things? So this will be so there are a lot of techniques to deal with. So just to mention, you can have some cluster of words, right? Cluster of words and retain with each word assigned to multiple different clusters like bank 1, bank 2, etc. And then you make a judgment based on the clusters, right? So you analyze the huge text, right? You got vectors, right? But you have some clusters, right? Clusters representing different maybe classes, and based on that you interpret the meaning of the vector while doing the NLP task, right? So we won't go to the details of this paper, but we will come back to these aspects later. So similarly, you can do something like you take different senses and maybe do some linear superposition of these things. So for example, the vector pike will be a linear combination of the vectors that you have learned. So pike 1 is one vector, pike 2 is another vector, pike 3 is another vector, and you give some weightage for these vectors and you make a linear superposition. Linearly you just make an addition and then use this pike, right, for the task. So this work is very recent work. You can see that in 2018 they have done this, and you can see there is very surprising results. They actually got it from the work, right? So you can actually separate out these senses, right? If they are coming very common, if the words are very common, then you can actually separate out these senses, right? So for example, suppose you are taking a word tie, right? So tie will have different senses, right? So it could be something related to the dress that we wore, right? Or some kind of a some game related kind of a championship, right? League, right? Then some other senses also there. For example, electrical related. There is a word called tie, right? So by just approaching this problem with a superposition of all the vectors that you have learned gives very surprising kind of a result. That's what this paper says. Right? So maybe I will. Okay, I think I have to spend some time on classification kind of task. So for that, so these are just introductory slides. I don't want to spend much time on this. So what is a classification problem? Basically, you have to have a training data sets consisting of samples, and you have input represented as xi's, and yi are the labels. So labels are basically representing the classes, right? So for example, a class could be a sentiment class, a positive sentiment or negative sentiment or a neutral sentiment. So there are three classes. There could be named entities representing classes like persons, organization, etc. Right? Then decision, buy or sell kind of a decision are representing the class. So what we do in the classification problem, basically we wanted to see a boundary which separates the classes, right? So a linear kind of a boundary we expect, and we try to classify the things, right? So usually we use a linear decision boundary because it's very simple to use, right? Then we know softmax or logistic regression to determine the hyperplane as a boundary, and we know how to predict, right, using this expression. So softmax basically gives you this kind of an expression, right? So these things actually we know, we have already seen this. So just refresh yourself how the classification task works, right? What is the role of softmax function there, and how we can deal with multiple classes, etc. Right? And maybe the idea of cross entropy, maybe loss function. So these things I think you have covered in the machine learning class, so there's no need to explain it. Now we are going to relate this with the classification problem in the natural language processing, right? So we will just refresh all these things, all these ideas, and since our paper is on deep neural network, how basically you can see the linear boundary as a neural network, right? So how the decision boundary is being defined by a neural network. So this is very important. So you have to see how a softmax function basically is represented by a neural network, right? So that you have to try to understand, and what is the linear and non-linear boundaries in the context of classification, right? How non-linear boundaries are being defined. So these things maybe you can just refresh. So this is a neural model. Neuron is represented by this kind of a function, right? So this is a softmax kind of a function, 1 over 1 plus e to the power of minus z. So here the weight, bias, and hidden layer, etc. You should refresh it. Then how to run a different. So basically, what is the connection between a logistic regression and a neural network? Right? You have to make a very clear understanding of these things are actually the same, right? So please try to refresh whatever you have learned. So I think I will stop here. So these are just refresh of what we have seen already. So with this, I would like to stop here, but I wanted to discuss a assignment problem which you can start doing. Let me take that. Yeah. Okay. So yeah. So one problem you have to do by yourself is a classification problem. Classification of emails using deep neural network after generating term frequency, inverse document frequency. I hope you might have seen or you might have learned the idea of TF IDF. Anybody, can anybody explain what is TF IDF?
So frequency?
What is that term? TF IDF representation, what is that? Term frequency, inverse document frequency.
Term frequency.
How many times a term appears in a document?
Oh, so it's basically an indexing kind of a scheme, right? Maybe you wanted to generate an index for a textbook, for example, right? So you list down the terms, right? And basically you wanted to point to those appearance of terms in the text using the page numbers, right? So that's basically indexing, right? Are you familiar or not familiar?
Yes, sir. I think we know
Yes,
that.
sir.
Yes.
Yeah, last semester in Foundations of Data Science, we studied just introduction of this.
Okay.
How to solve small simple problems.
Okay, right. So assignment is very simple. You have to have you have to take a data set which consists of email database and construct a very simple neural network. Even though it is written as deep neural network, you can construct a very simple neural network and try to classify those emails based on maybe some predefined classes, right? So for example, let's say a computer is a class, right? So wherever the word computer or related term with computer comes, you classify that those emails are related to queries related to a computer, something like that. You can or you take the data set and see how they have labeled it, and you can take those labels as a different classes, and you can train the neural network and then classify it, right? But you can see if you are using frameworks, as I told you, you can use PyTorch as a framework to do all the tasks, right? and you can use NLTK library or GenSim library for doing all these tasks. So there will be predefined neural networks, pre-trained neural networks available. Using that also you can produce results and show me, right? So one implementation of a simple neural network and your task, and then you can use predefined, pre-trained networks to do a classification. So you can go through the textbook. So this is an excerpt from a textbook. So I will upload it in the Moodle site. You can download it from there. So this maybe explains what is CNN and all. You can read if you want. And AlexNet, which is a very famous image net kind of a thing. Then RNN is also given here. I think these aspects will be covered in the other paper. And how RNN are used in NLP. So language modeling, text generation, machine translation for building chatbots, then generating an image description, etc. So this is the task. So classification of emails using deep neural networks after generating TF-IDF. So deep neural networks to classify emails into one of the 20 pre-trained categories based on the words represented in each page. Right? So this simple model to start with to understand the subject of deep learning and its applications in NLP. So here they have given some code snippets. Need not be in PyTorch, plain Python might be. So there is a data set, a news group data set, which is available in scikit-learn. Okay? You can take the data set from there. So there are a lot of observations and training this much data. For test observation, this much data is there. Okay? So categories are 20. So you can train it and so you know the pipeline, right? So please remember the always you have to remember the pipeline that we have defined in the first class itself. So how an NLP pipeline must be defined for the tasks, and using that pipeline you have to do this. So pre-processing, removal of punctuations, tokenization, converting words into lowercase. So all this you can use just NLTK library for converting this. Stop word removal, everything is available, libraries are available. Then keeping the words of length at least 3, right? The stemming words, basically removing the ing or maybe any prefix or postfix kind of a thing with a word. So basically it's called stemming. Then post tagging, parts of speech tagging. Then lemmatization of words. So basically you can use TF-IDF for vector conversion, right? So here the representation of the word is basically TF-IDF representation, right? So we have seen word-to-vec and the globe, but this is a simple kind of a representation. So all the words basically we convert it into a TF-IDF vector, right? And based on that, you have to train the network and test the network, then evaluate the results, right? So you can refer this. You can do all the pre-processing things using NLTK. So that is available. So everything is explained here. You can just try in Colab. And they have used Keras, but I advise PyTorch. You can use PyTorch for doing that. So you just try to mimic whatever done in the Keras, try to do it in PyTorch, right? So I think we can do that, and finally you can come up with the results. So basically the prediction using precision and recall, and F1 score you can report, and the support also you can report. So all those things we have libraries, you can use that, right? So this is a typical exercise, or maybe in NL, maybe NLP, so that most of the problems that we are going to address will be similar to this, right? So please try to understand the problem first, and try to understand all the blocks required to solve the problems, and please try to understand how to evaluate and report on the results, right? Typical NLP task, right? So with this, I think I will give 1 month time. So today is 10th of March. By 10th of April, you can submit the first assignment, right? So I won't wait till the end of the semester, right? So we have to do a lot of things in this class, right? So, please start doing the assignment. So let me take the attendance and stop. Okay. Naji Abu,
Present, sir.
Remina Ali,
Present, sir.
Hasna CA,
Yes, sir.
Hadia,
Yes, sir.
Bipin,
Present, sir.
Bindu,
Present, sir.
Santosh,
Present, sir.
Jitesh,
Present, sir. Present, sir.
Kanagambaran,
Present, sir.
Jasara,
Present, sir.
Hindu,
Present, sir.
Leena,
Present, sir.
Vikas, Simi,
Present, sir.
Sandeep, Sandeep, Sandeep is not there.
He's not there.
Not there, sir.
Sanila,
Present, sir.
Divya, Divya is there, right?
Present, sir.
Okay, okay. Okay, so thank you.
Okay, sir.
Thank you,
Thank you
sir.
very much.
Yeah, so
Thank you, sir.
we will meet next Tuesday. Okay.
Okay, sir.
Okay, sir.
Yeah.
Thanks, sir.
Okay.
Thank you, sir.
Thank you, sir. Thanks.
Have a nice weekend.
Thank you, sir.
Thank you, sir.
Thank you.